Okay guys, we're starting off with our quantitative test now. So we're done qualitative, trying to detect if something is there. Now we're doing tests to find out how much of something is there, okay? And you can break these broadly down into two ways, okay? And I've put them in bold here. We've got chemometric quantitative analysis, fancy word for using a chemical reaction to form a precipitate and then weigh the precipitate. Okay, and then the next one is instrumental quantitative analysis, using a machine to look for something, say absorption, which is proportional to concentration. Okay, so first up we're going to talk about this one: investigations and processing data involving gravimetric analysis and precipitation reactions. Oh, sorry, precipitation titrations. So back to titrations. So I've got two methods here for precipitation titrations. They're the most common. There's a third one in the textbook if you want to go into it. The first one is called Moore's method, and it's determining what we're looking for is the amount of either chloride, bromide, or cyanide by a direct titration with silver nitrate. Okay, and you've also got the chromate ion as an indicator. Okay, so we've got a sample with an unknown amount of chloride, bromide, or cyanide, and we're going to add silver nitrate to it dropwise in the burette. Okay, it's going to react and precipitate out, and then the first bit of silver that I put in, once all the chloride, bromide, and cyanide are taken away, that first silver is going to react with the chromate to form silver chromate, which will turn that pinkish color is formed. Okay, so before titration you're going to have some unknown color, you're going to start precipitating and it'll go white with the silver highlights, white cream or something like that, and at the end point, once all that analyte is taken up, the next drop of silver is going to form silver chromate, and it gives it that pink color, and that's our end point. Okay, the end point does not occur instantly in this, so blank titration is often done. Yeah, so you have a sample that has everything else except the analyte in there, except the chloride, bromide, and cyanide, and you do a titration and you wait for that pink endpoint. Okay, and that helps refine the calculation. Might be a bit too much detail here, but that's okay. All right. A Moore's method titration was conducted to determine the quantity of bromide in a solution using a chromate indicator, just like I said there. The silver solution was silver nitrate of a concentration of 0.10 moles per litre. A blank titration was conducted on a 25 ml sample with no bromide present, and the chromate endpoint was measured at 0.65 millilitres. The titration was conducted 3 times with 25 ml aliquots of the bromide solution, and the average titration volume was 18.9 millilitres. Determine the bromide concentration in the samples. Okay, a lot of words. So when they did do the titration, the average titration volume of silver nitrate added was 18.90 mil. And we talked about earlier that there's kind of like a lag in there. I'm going to use the term lag. Okay, you did a blank, and the blank was measured at 0.65 mil when you had 25 mil. So the actual amount of silver added was 18.9 mil, or the actual silver added to the endpoint, 18.9 mil minus 0.65 mil of that blank. 18.25, is my math correct? I should have my calculator in front of me. You're all probably laughing at me right now. He can't do simple maths, but in the exam, put it in your calculator anyway. 18.25 mil. Phew! Thank you, calculator. I am right. Okay. Just getting my periodic table in front of me. So it required that volume, and we've got a concentration of silver plus. Okay. It's the same concentration of the silver nitrate. Silver nitrate has that formula. So the concentration of silver pluses is the same concentration because it's a 1-to-1 mole per litre. So we can tell here, because we have the concentration of volume, how many moles of silver to endpoint equals our concentration times by our volume in litres, 0.01825 litres, which is going to be I should be able to do this in my head, shouldn't I? 0.01825. Yeah, I should do it in my head, but I'll put it in my calculator. 1.825 times 10 to the negative 3 mole silver. And because this formula occurs, we're testing for bromide, aren't we? Gives silver bromide. It's a 1-to-1 ratio, so therefore 1.825 times 10 to the negative 3 mole of bromide, and it was in a 25 ml sample. So the concentration of bromide equals the number of moles divided by the litres, 0.0250 litres. And I get 0.073 moles per litre for my bromide concentration. Alright, there's another example from the textbook. Let's talk about our other method, which is very similar in that it still uses silver nitrate, and you'll still see the chloride, bromide and cyanide there, but you'll see it analyzes for a lot broader. Okay, and it analyzes for a lot broader because it's a back titration. Okay, so Volhard's method is similar to Moore's method, but it's a back titration instead. Okay, so here we're dumping in a whole lot of silver nitrate or putting in excess silver plus, and then what we're doing is, after that initial reaction's gone through, we're titrating against the excess silver plus. Okay, so we're going to dump a whole lot of silver nitrate in there, and then we're going to filter the precipitates out. Okay, and then that solution that's left over with excess silver plus, we're going to then titrate with a solution of potassium thiocyanate, KSCN. The thiocyanate ion is SCN single minus. Okay, there's an indicator in there which is an iron 3 salt. So the thiocyanate will preferentially go for the silver, but once all the silver's taken out, the thiocyanate will then react with iron, and you'll get a color change. It looks like it's pinkish as well. Okay. Alright, our strengths for our Volhard method. It's more accurate than a direct titration. Okay, you saw the lag, well, the lag and like the blank for the direct titration. It also analyzes for a lot more, doesn't it? You can analyze for the chromate ion in there too. Limitations. If there's a mixture of anions, it can only determine the total anion concentration, assuming that your stoichiometry is 1-to-1 as well. So if you've got a mixture of chloride and sulfide, which have two different charges, it can only work out the concentration of negative charges there. Okay? It doesn't deal with the mixtures. So if you've got one pure substance in there, it's nice and good. Okay, you need a filter after the initial precipitation. For some it may not be needed, but some others the thiocyanate will displace the previously bonded anion. Going in a lot of detail here that we probably don't know, but it's a back titration, and let's do a problem. So a Volhard's method chemometric titration conducted to determine the sulfite content of a mineral. A 0.29 gram sample of the mineral was crushed and dissolved into 40 ml of nitric acid. And then 20 mils of this concentration of silver nitrate was then added to the mixture, and a precipitate was filtered. The remaining solution was titrated with the thiocyanate, and the endpoint was reached after this amount. Determine the sulfide content of the mineral as a percentage mass. A lot of words, okay? So we got some sulfide mineral. We dissolved it in acid, so it becomes soluble. So we got sulfide in solution. Then we dumped in a whole lot of silver nitrate. So we had some silver sulfide precipitate out. We filtered all that out, and the excess silver that was then titrated with the sodium thiocyanate. Okay, so what we can do is we can work out how much silver was initially added. And we've got that. We've got 20 mil, 0200 litres times 560 mole per litre equals, we'll put this in our calculators, and we'll get the answer of how much initial silver was put in there. So 0.0112 mole of silver plus added. And we can work out how much remained, okay? Silver plus was going to react with the thiocyanate ion to form silver thiocyanate. Okay, so it's a 1-to-1 between them. Okay, so it was titrated against, so we used 0.00980 litres, or the 9.80 millilitres, and a concentration of 0.680 mole per litre. And we'll get how much thiocyanate we used, and therefore how much silver was there. 0.00980 times 0.680 equals 6.664 times 10 to the negative 3 mole. SCN used. So because it's a 1-to-1, 6.664 times 10 to the negative 3 mole of silver was excess. So our mole of silver used initially equals the total, which equals the 0.0112 moles, minus the excess. So 6.664 times 10 to the negative 3 moles of silver excess. So what we dumped in there originally, minus what was left over at the end, will tell us how much was used. So 0.0112 minus 6.664 times 10 to the negative 3. So, well, 0.004536 mole of silver used in that initial dump in. And because, tricky, we had silver plus sulfide going to silver sulfide. Okay, so we needed 2 silvers for every sulfide. Don't forget your stoichiometry there. 2 silvers for every sulfide. So our moles of sulfide is going to equal our 0.004536 mole of silver used, multiplied by our moles of sulfide, 2 moles of silver. And our moles of silver is 2, and our moles of sulfide is 1. So we're going to divide that by 2, or multiply by half. 2.268. Oh, 2.268 times 10 to the negative 3. Okay, so 2.268 times 10 to the negative 3 moles of sulfide were present. We need a percentage mass, so we need that as moles of sulfide. So we're going to go grams of sulfide equals 2.268 times 10 to the negative 3 moles times it by 32.07 grams per mole, just the molar mass of sulfur. So again, back to my pencil, 0.0727 grams. Okay, so the percentage mass equals 0.0727 grams divided by the sample, which was 0.29 grams, divided by 0.29, times it by 100, and I get 25.08. Oh, look at all those three significant figures, so I can call that 25.1%. Okay, difficult question, worth a lot of marks. All right, a past textbook one, a past HSC paper one. You can see in the diagram they've got a water sample and they're dripping in silver nitrate solution. Okay, so they're essentially hang on, this is like a gravimetric analysis one, which we haven't talked about yet. We'll leave this problem till after we're done gravimetric analysis. Okay, there's a couple of worked examples from the textbook, and if you want a third Fajan's method or Fajan's method, 428 through 429 in the textbook, and then you can do those problems. Okay, next video we'll talk about gravimetric analysis.